Okay, before we start, any of you try any machine learning algorithm before, or maybe if you built a machine learning um, in any other languages, or this is the first time you heard about machine learning? So please let me know in the comments. So have you heard of machine learning, or maybe you take a course on machine learning before? If you're from the computer science, maybe you did. For this course, we're going to do it in Python. First, we're going to look at some introductions. And when we talk about machine learning, we have three broad categories, although there's only two maybe that people usually think of. So we have first the supervised learning, and we have unsupervised learning, and the third one we have reinforcement learning. So these are the three different algorithms for machine learning. And based on these three algorithms that we have, we can do some kind of performance evaluations so that we can evaluate how good is the learning or what's the accuracy of all these three different models. This is the quotes just now. I said that if you still remember Alan Turing from our topic 1, so he's the guy that came up with the Turing test. So the test that for us to rate how good is our AI is. So whether they have human intelligence or whether they can pass the test. Machine learning is a subfield of artificial intelligence. So I said previously, like in our lecture topic 1, so under the topic AI is a very big umbrella. Under AI, we have all these different fields. So we have machine learning, we have deep learning. We're going to look at deep learning next week, and all are the others. Okay, our goal is to understand the structure of the data and fit the data into models that can be understood and utilized by pupil. So that means we have machine learning with traditional computational approaches. So in the traditional computing, the algorithms are set to explicitly program instruction used by computers to calculate or problem solving. So you can think of it as a simple if-else. So if you have if certain command and then else what it's going to do. So that is the algorithms that we explicitly program with instructions. But with machine learning here, it allows the computers to train on the data inputs, and we can use statistical analysis in order to output the values that fall within a specific range. So the key term here is that we can train on the data. Any technology user today can benefit from the machine learning. So these are some of the examples that we encounter every day. So we have facial recognitions. So if you go on the social media platforms, and if you upload a picture and then, for example, the Facebook maybe would suggest you to tag that person as your friends that you have previously tagged before. And we also have like OCR, optical character recognition, so we can convert images of text into recognized character. What happened here? We have an algorithm that we have fed it in a lot of like different data of different kind of character in ideal stage or maybe different type of stages, and we can train that algorithm to understand this kind of different images, and it can recognize all the different character when we try to plug in with different images. And this is another one, the recommendation engines. So it suggests you with movie or televisions to show to watch based on your preference, for example, like Netflix. So these are like the different ones. So this one is facial recognitions. Here we have automatic license plate character recognitions. And here we have recommendations. So these like all the other examples. These are the three different algorithms I mentioned just now. In machine learning, the tasks are generally classified into broad categories. So these categories are based on how the learning is received or how feedback on the learning is given to the system developed. So based on how the learning is received, we have three different methods or algorithms. First, we have a supervised, we have unsupervised, and then we also have reinforcement learning. For supervised learning here, the key word is label. supervised learning, we train algorithm based on example input and output data that is already labeled by humans. In unsupervised learning, the keyword here is unlabeled data. So in unlabeled data, that means we don't label what's the output from the given input that we have, and the machine is going to find the structure within the input data. And the third one, we have reinforcement learning, where we have agent. So the agent going to learn by interacting with its environment. So they have like reward or punishment for the learning experience. Okay, first let's look at this supervised learning. Okay, in supervised learning, the computer is provided with example of inputs that are labeled with their desired outputs. So the goal here is to approximate the mapping function so well that when you have a new input data, then you can predict the output variables for that data. So the purpose here is for the algorithm to be able to learn. So it's going to learn by comparing its actual output with the taught outputs to find error and modify the model accordingly. So the learning is based on what they have been taught previously. So with supervised learning, we can use patterns to predict labels value on additional unlabeled data. For example, we have an algorithm fed with variety of images of cats labeled as cats. So you can see in this image here, so this like all the different kind image of cats, different breed, different kind of cats look. So by being trained on this data, the supervised learning algorithm should be able to later identify whether the next image going to be fed on is a cat or not cat. So step 1, we provide the machine algorithm, categorize or label the input and the output data from the learning. So this one in step 2, we feed the machine with a new unlabeled information. So after we have done with the training, and then we fed it with different kind of different look of the cat, then it's going to identify, comparing whether this one is a cat or not with the previous learning. And based on this one, this is a new unseen data. So it's going to compare this one with the previous learning. So they can know that, okay, this one is not a cat, so it can label it as not cat. So these are some of the common use cases for supervised learning. So we use it to use for historical data to predict statistically likely future events. For example, in the stock market predictions, to anticipate upcoming fluctuations. You also can use it to predict user tendency to subscribe to certain telco package. And you also can use it to filter out spam emails. Under the supervised learning here, we have another 2 terms here. The first one is classifications. So this is another approach under the supervised learning. So classification problem is when the output variable is a category. For example, we have red or blue, disease or not disease. So if you look at this image, this is like a classifications. So we can sorting items into categories. So this is the blue categories, this one is the red categories. For regressions here, a regression problem is when the output variable is a real value, such as dollar or weights. Is another example of supervised learning. So here you have input raw data. So this one, I think it's a tomato. Yeah, it's a tomato. So you have a lot of different kind of tomatoes, maybe with different color, different shade, different look, slightly different shape, but it is still, we label it as tomato. So you can train it. So this is the algorithm. So inside this algorithm, you have a training data set. You train it, and this is our desired output. And it's going to process it. So this is the model training. So based on the model that we train, which is this one here, then we're going to feed in with an unseen data. So this is another tomato that never exists. It never exists in this data set before. So this is another type of tomato, maybe different shape. So we're going to plug in into our model here that we have trained, and it's going to tell us whether it is a tomato or not. In unsupervised learning, it's just the opposite. Our data is unlabeled, uncategorized data, and the system algorithm acts on the data without prior training. So the output is dependent upon our coded algorithm. So subjecting a system to unsupervised learning is one way of testing AI. Okay, so we have given some characters to our model, which are ducks and not ducks. In our training data, we don't provide any label. So we don't label it whether it's a duck or not. So the unsupervised model is able to separate both the characters by looking at the type of data and analyze the pattern in order to learn more about it. These are the two different types of unsupervised learning. We have clustering and association. So in clustering here, we want to discover the inherent groupings in the data. For example, we want to group customer with different purchasing behavior. And we also have association to discover the rules that describe large portions of our data. So for example, we have rule, for example, for people that buy X, they also tend to buy Y. So for example, maybe for people that buy bread, they also buy butter. People that buy milk, they also buy cereal. And next we have reinforcement learning. So what is this reinforcement learning here? Is the learning by agents or learns by interacting with its environment. So the agent receive rewards by performing correctly, and if they perform wrongly, they're going to receive penalties. So this learning without intervention from a human, so we don't have to intervene with it, but we're going to set that it's going to maximizing its rewards or it's going to minimizing its penalty. So you can think of it, for example, if you're going to train a dog, so this dog is our agent. This is the environment here, so it starts from sitting, and then we have a set of actions. Then if it walk correctly, if it sit, then we're going to provide it with a reward. So it's leveraging the rewards obtained, then the agent improve its environment knowledge to select the next actions. So this is an example. So we have input, which is an apple. It is not labeled. So if you look at this part here, this is the response. So if the agent guessed wrongly, then the rewards are subtracted. And the agent tries to learn that it's not a mango. But if the agent guessed correctly, then some points would have been added to the rewards point. So the agent then would try to learn that's the image of an apple. To recap, these are the three machine learning methods. So we have unsupervised learning, supervised learning, and reinforcement learning.